Welcome to the Coqui TTS demo tutorial. Today, we'll build a desktop application using PySide 6 that lets you download, manage, and use Coqui TTS voices to convert text into speech. By the end of this tutorial, you'll understand how to combine a graphical user interface with background processes and audio playback, essentially, creating your own text-to-voice editor. First, let's get your environment ready. You'll need Python and the PyCharm IDE installed. Let's start by downloading Python. Open your web browser and go to python.org/downloads. Click on the Downloads menu. Click on Windows in the drop-down menu. For this tutorial, we'll be using Python version 3.11.9. This is important because Coqui TTS doesn't fully support the very latest Python versions, and 3.11.9 is the most compatible one. Since I'm creating this tutorial on a Windows 11 machine, I'm downloading the Windows installer. If you're using a Mac or Linux system, be sure to download the appropriate version for your operating system. Now, go ahead and click on the Windows installer, 64-bit, link. Let's open the file you just downloaded. Be sure to check the box that says Add Python to Path. Click Customize Installation. Click on Next. It's really important to use virtual environments when you're working with Python, especially in PyCharm. This means the main Python installation needs to be accessible system-wide. If you don't check this box, it installs just for your user account, which limits its use. So, go ahead and check the Install Python 3.11 for all users box. Now you'll see Python is being installed directly into the Program Files folder. Go ahead and click the Install button. Great! This page confirms that Python has been successfully installed. Go ahead and click the Close button now. Open PyCharm and click the New Project button. Let's start a new project called Coqui TTS Demo. Before we proceed, we need to confirm we have the correct base Python installation set up to create a virtual environment. You might already have the right version of Python selected, especially if you only have one installed. However, it's common to end up with multiple versions on your computer. If that's the case, make sure you choose the correct one. For this Coqui TTS demo app, we need Python version 3.11. I'm going to let you make a mistake. Leave the Select Existing button selected instead of choosing Generate New. Then I'll show you how to fix it after you've already clicked Create. Click the Create button. Click the Exclude Folders button in the lower right corner. This will prevent Microsoft Defender from interfering with your IDE. We need to update some components of the virtual environment. Click on the File menu. Click on Settings. Click the Python option. Click the Interpreter option on the right. It's essential to verify your virtual environment. At the moment, the Python interpreter is pointing to the system's default path, not the project's folder. The path shown should include the project directory. This happened because you left the Selecting Existing radio button checked, which I made you do it on purpose, remember, so instead of creating a .ben folder and copying the base Python files into it, the project was linked directly to the system Python interpreter. Let's make sure we're using the correct Python environment. Click the little down arrow next to Python interpreter. Click on the Show All option. Okay, this is the Python interpreter we downloaded and installed, the base installation. But remember, we want a separate Python installation within each project's virtual environment. So, let's remove this one. Click on the minus button. Click the OK button. Click the Add Interpreter button. Click Add Local Interpreter. Now, let's choose the Python installation for our virtual environment. This setting dictates which Python version will be used for our project. We need to select 3.11, even if you have a newer version installed. That's because we know for sure that Coqui TTS works best with Python 3.11. The key point is to avoid leaving the Select Existing option checked. Now we confirm that the Generate New radio button is selected. The virtual environment is created in a folder named .ben in your project's main directory. Click the OK button. We've installed the initial packages for our app. Notice the up arrows, they mean those packages need to be upgraded. Click the pip package. Click the upgrade button. Select the next package. Click the upgrade button. Install the required package by clicking the install button. Pyside 6 is the official Python binding for the Qt 6 application framework, letting you build cross-platform apps that run on Windows, Mac OS, Linux, and embedded systems, all with Python. Qt provides powerful tools for GUIs, servers, and industrial control, and Pyside 6 gives you access to its widgets, layouts, signals, and slots, and more, using familiar Python syntax. This lets developers combine Qt's robustness with Python's simplicity and rapid development. Click the Install Package button. Close the window that shows the available packages. Click OK to close the settings window. Pyside 6 lets you build user interfaces for Python apps. Create a new Python file to write the main window code. Right-click your project folder. Point to the new option. Click on Python file. We'll create two Python files. The first, mainwindow.py, contains the code that draws the application's UI. The second, main.py, launches the window. This separation lets you design the UI independently from starting it and setting properties like the title, centering, or maximizing. Now type main window and press enter. Let's get started. We'll build a simple Pyside 6 window and I'll walk you through each line of code. First, we're importing the main window class. This is essential because our custom main window will inherit from it, which is necessary to create a main window in a Pyside 6 application. Now, let's create our main window. We're declaring a new class called mainWindow, and it'll inherit from the QMainWindow class from Pyside 6. Next, we examine the constructor. It creates a new instance of our class, and you must call the parent class's constructor with super __init__, to initialize it properly. Let's create the main Python file, the entry point of your application. Right-click your project folder. Point to the option called New. Click the Python file. Name the new Python file main and press enter. Let's break down how this code starts your Pyside 6 application. First, we import the necessary tools, including the QApplication class, which manages the app's main loop. Next, we load your custom main window class, that's where your main user interface is defined. Inside this block, we create the application object, create the main window, and then show it on the screen. Finally, the last line runs the event loop, keeping the application running until you close the window. Let's run the application and see if the main window appears. Right-click inside the main block. Click Run Main to start. Our current Pyside 6 application is minimal, it has no UI controls yet. The goal was to set up the environment and create a main window, ready for the next phase. In that phase we'll add controls that interact with the Coqui TTS engine to turn any text you type into natural-sounding audio. Close the main window. Now, click on the Terminal button. Let's look at another way to install Python packages. This time, we'll use the Terminal panel. To install a package, simply type pip install followed by the package name. For example, to install the wheel package, type pip install wheel and press enter. You'll see feedback in the terminal showing you what happened and whether the package installed correctly. Now install the PyTorch package with CUDA support. If you have a GeForce RTX GPU, this is essential. Double-check your command, then press enter. You'll see feedback in the terminal window, confirming that the packages have been installed. Now install Coqui TTS. In your terminal, type the command exactly as shown, then press enter. The yellow highlight in the screenshot shows that, among all the detailed output pip install provides, it confirms the package was installed successfully. Let's confirm your GPU is working. Type the command you see highlighted on the screen, and then press enter. You should see a result confirming your GPU is available. This confirms I have an NVIDIA GeForce RTX 4080 Super graphics card installed. Now, let's see what voice models are available. Type the command TTS list_models and press enter. You might see a warning pop up as you follow these steps. Don't worry, it's not an error. It's just letting you know that a helper module called package_resources is being phased out. It might be removed in late 2025 or 2026. Coqui TTS, and many other Python libraries still use it, so you can safely ignore this warning for now. Future versions of Coqui TTS will eventually update to use a different method. Just keep in mind that you can keep your installation current by updating setup tools and Coqui TTS with this command: pip install upgrade setup tools Coqui TTS. The TTS list_models command shows you all the pre-trained models available for Coqui TTS. They're organized into 3 groups: TTS models, vocoder models, and voice conversion models. These are text-to-speech models. They take written text and transform it into MEL spectrograms, which are essentially the acoustic blueprint for speech. The naming convention follows a /separated path. The first segment names the model family. The second specifies the language. The third indicates the training dataset or source. The last describes the architecture or variant. Together, these 4 parts uniquely identify the model's origin, scope, and structure. In this example, the voice model name shows a language code, N means English. In choice 11, the highlighted term is the dataset, the data used to train the model. LJ-Speech is a well-known public dataset featuring a single female English speaker reading passages from books. Each architecture, like Tachytron 2, VITS, or Glow TTS, represents a different way we build these neural TTS models. This is an English model, trained on LJ-Speech, using a Tachytron 2 architecture. Vocoder models are the final step in text-to-speech. They take the visual representation of sound, called a MEL spectrogram, and transform it into the actual audio waveform. The vocoder is what determines the final sound quality and how natural it sounds. This is an English vocoder using Hi-Fi GAN version 2. Vocoders work with text-to-speech models to generate audio. To use it, pair it with a compatible TTS model. For example, you can generate speech by using the command TTS text hello model _name TTS _models /n/ speech /tachytron 2 DDC vocoder _name vocoder _models /n/ speech /hifigan _v2. Voice conversion models change the sound of a voice to make it sound like someone else. Oh yeah. I know what you are thinking, and you are right. Yes, you can do that, you just need 6 seconds. We can transform one voice into another using Freak24, which relies on the VCTK dataset. Generate your first audio file. Type TTS, then a double quote, the text you want to speak, and another double quote. Add model _name and the full model name, for example TTS _models /n/ speech /tachytron 2 DDC. Press enter. A WAV file has been created. You'll notice the WAV file was created in the project's main folder. Let's give it a play. Okay, we've installed everything we need for Coqui TTS and created a sample audio file. Now, let's integrate it into our PySide 6 application. We'll add some controls so you can type text and generate audio. First, we need to install a couple more Python packages. Please type pip install PySide 6 playsound == 1.2.2 and press enter. You probably saw the already satisfied messages. I put them there on purpose to show that pip can install multiple packages in one command. PySide 6 was already installed, earlier we added it via pycharms file settings. This package lets us play sounds directly in our app. It's straightforward, just as the name suggests. We'll use it to play text-to-speech audio within our application. Okay, let's refactor the main window class. We'll add a table to display all available voices, with buttons to download and install them. This table will also let you select an installed voice. Below the table, we'll include a text area where you can type the text you want to convert to audio using the chosen voice. Let's break this down step by step so you can see exactly what you'll need to type. This section sets up all the essential tools we're going to use to build the TTS voice editor. We're importing modules for handling background tasks, running commands, and accessing files. We're also bringing in everything we need from PySide 6 to create the graphical interface, windows, buttons, text boxes, and everything else you see. Finally, we'll be using these tools for event handling and styling the look and feel of the application. With these imports, we're ready to build a fully interactive desktop app to manage and play your Coqui TTS voices. This class manages downloading TTS voice models in the background, so the main interface stays responsive. It uses a special system to update the main window with progress messages while the download happens. When it starts, you'll see a message confirming the download has begun. Then, it uses a command line tool to download and check the model, creating a temporary audio file along the way. If everything goes well, you'll get a confirmation. If there's a problem, you'll receive an error message instead. This ensures a smooth and informative download experience. This window manages all of your Coqui TTS models. It's a separate pop-up window, and when you choose a voice model, it sends a notification to the main application. This lets the main application know exactly which model you've selected. Now we'll build the main structure of the Model Manager window. First, we set the title and size. Then, we're using a vertical layout to keep everything organized. At the top, you'll see a horizontal section with 3 key controls, a search bar, a rescan button, and a show cache route button. The search bar allows you to filter the list of models by keywords, like their name, language, or architecture. The rescan button updates the list to reflect any new installations. Finally, the show cache route button will open the folder where your models are stored. These controls give you easy access to explore and manage your TTS models. Let's create the main table. This is where you'll see all your TTS models. It has 3 columns: model name, installation status, and a button to download or reinstall. The model names will expand to fit, while the other columns will adjust to show the necessary information. Selecting any cell will automatically select the whole row, making it easy to manage your Coqui TTS voices. Now, let's add a button to confirm your selection and choose a TTS model from the list. Clicking this button will send your choice back to the main window after a quick check. This window also organizes all available models and the ones you already have installed. And, as soon as you open this window, you'll see a table displaying all models, ready for you to browse or install. These methods help you manage your TTS models and access local storage. Load_models get your list of available and installed models, populating the table with that information. Rescan refreshes that list, ensuring you see any new downloads or removals right away. Finally, show_cache_route will show you where Coqui TTS saves those voices, so you can easily find them on your computer. We'll list all Coqui TTS models by running TTS list_models. Next, filter the output to keep only names that start with TTS_models/. Then remove duplicates and sort the list alphabetically. If an error occurs, we'll let you know. This method checks your computer to see which Coqui TTS voices you already have installed. It looks in the TTS cache directory, usually found in your app data folder on Windows. Each folder containing a config.json file is considered an installed voice. To match the standard naming format, we replace the double dashes used in the folder names with slashes. The result is a clear, alphabetized list of all your locally installed voices. This method makes the table display all the text-to-speech models and their status. It's cleared and refreshed each time. Each row represents a model, showing its name and whether it's installed, green for installed, red if not. You'll also see a button that changes to either reinstall or download based on the model status. Clicking these buttons lets you easily install or reinstall any voice directly from the table. This method shows the code that powers the search box. Type a word or phrase and the list filters to show only matching voices. Clearing the box restores the full list. It makes finding the perfect voice quick and easy. We'll cover 3 methods. First, download model starts a background task that downloads the chosen model, updates the UI with progress, and auto begins. Second, Show Progress displays a message box with the current download status and then refreshes the model list to show any finished downloads. Third, Select Current Model checks that a model is selected, warns if none is chosen or if it isn't installed, and otherwise confirms the choice and activates the model. Together, these methods provide a simple, user-friendly workflow for downloading, tracking, and selecting models. We're now building the main application window. This is where you'll type or paste text and convert it to speech. The window title is set, and we've chosen a default voice to start with. Inside, you'll find a large text editor. Feel free to type or paste anything you like. At the top, there's a toolbar with two key buttons, one to open the voice manager, and the other to play back your speech. Finally, a status bar at the bottom will give you real-time feedback, like when voices are downloading or being synthesized. This is the core of the TTS voice editor. Now let's look at how the app lets you pick which model to use. The Open Model Manager method opens a separate dialog window where all available models are listed. When the user selects one, that dialog sends the chosen model name back to the main window through a connected signal. The Set Model method then takes over. It saves the chosen model as the active one and updates the status bar to confirm which model is now selected. Together, these two methods let the user browse, choose, and activate a model for speech synthesis in a clear, guided way. Now let's go over how the program converts text into speech. The Play TTS method starts by reading the text from the editor area. If the user hasn't typed anything, it shows a warning message asking for text input. Once text is available, it retrieves the current model and updates the status bar to show which model is being used. Inside this method, there's another function called Run TTS. It runs a command in the background that uses the text and the selected model to generate speech. After the voice file is created, the app plays it automatically and updates the status message to Done. If any error happens during the process, it catches the error and displays it on the status bar. Finally, this whole operation runs on a separate thread, so the user interface stays responsive while the text is being synthesized. In short, this section handles the entire speech generation workflow, from user input to audio playback, smoothly and asynchronously. Now it's time to test the code. Click the Run button to launch the application. Here's the UI in action. The title bar reads TTS Voice Editor, which is set by the self.setWindowTitle call. Let's explore the toolbar. The Manage Voices button opens a list of all available voice models. Here, you can see which voices are installed and download new ones with just one click. Continuing our UI tour, the next button on the toolbar is the Play button. It will read aloud, using the voice you selected in Manage Voices, whatever you type in the large text area below. Below the toolbar is a large text field where you'll type your text and click play to hear it spoken. Now that we've finished the UI tour, let's get started. Open the Manage Voices window by clicking the Manage Voices button. I've already installed a few voices. Feel free to download more to match your preferences. Let's narrow down the list using the search field. For example, typing N will show only the voices that speak English. Click on the row header to select a voice. Click the Select Model button. Finally, type some text into the field so the app can convert it to natural voice audio. I typed "This is a test," you can enter the same or something else. And now, click the play button to hear it. The status bar shows you whether the code is currently generating the voice. When the status bar shows done, you should also hear the voice stop reading your text. Congratulations, you've finished the Coqui TTS demo tutorial. You now have a working Pi-Side 6 app that lets you download, manage, and use Coqui TTS voices to produce natural-sounding speech. In this tutorial you built a graphical interface, used background threads for responsiveness, ran TTS commands, and played audio directly inside the app. This gives you a solid foundation to customize the interface, add features like saving audio, or tweak voice settings. Thank you for following along and creating something new.